All right, g'day everyone. I'm Nate Butterworth from the Sydney Informatics Hub, and today we are going to learn all about cloud computing, especially in the context of Sydney Uni and what's available here. I'm phoning in from Gadigal land, so I'd just like to acknowledge my respect to elders past and present, and hope to continue a culture of learning and knowledge and discovery that the Gadigal people have lived for many years. So yeah, I'm from the Sydney Informatics Hub, and if you haven't heard of us, we're part of one of the core research facilities at the university, and we provide data analytics, data science, statistical consultancy, collaboration and training for researchers all across the university. We cover areas such as AI, machine learning, bioinformatics, computer vision, visualization, software development as well, and that is over all research domains. So we offer advice on sort of training and support for university computer infrastructure, so like cloud computing, but also data storage, RDS, as well as other digital research tools and software as well. And as I mentioned, we're going to talk all about cloud computing today. So yeah, feel free to drop any questions that you might come up just in the chat, or you can even interrupt me if you like. So let's get started. I've got just a handful of slides before I get into a few demos. Okay, so the very first question, what is the cloud? If you're coming at this from a novice background, Wikipedia tells us that cloud computing is the on-demand availability of computer system resources without direct active management by the user. Now, I think that's a pretty broad but pretty good summary of what cloud computing is. Or as Stenny from our team said to me, he said it's someone else's computer, which I think is a good way to think about it, although he didn't want that quote attributed to himself. But there we go, that's where I heard it. And yeah, you can think of cloud computing, I guess traditionally it may have been like a lab computer that people log into, or just any kind of remote system, something like Artemis and a high performance computer where you can log in and, it's managed by someone else, and you just log on, do your work, and then log off. I guess, yeah, traditionally it was a bit of a shared resource. But now when people talk about cloud computing, they're mostly referring to something that I guess is just available for yourself. So so it's not, it now lives in like a big data center, and it's sort of your own computing resources that other people are still taking care of. So they're managing the hardware, they're managing the network, and plugging in all the cables and making sure things are updated, and all the cables are working and the drives are functioning and replacing things as they break. But I guess it's still someone else's computer, just a little bit more professionally managed these days. So that's what I think about when we talk about cloud computing. And to put this in sort of context globally, the cloud, this image shows the cloud infrastructure services market from 2018 to 2023. And this is the total revenue. So we're talking sort of tens of billions of dollars, and it's just growing sort of at a very good rate. So it's definitely a growing industry as people and services and computing moves into the cloud, I guess. And so there's a couple of terms here I should just point out. This IaaS, PaaS, hosted private cloud, and there's another one, SaaS, SaaS, PaaS. I don't know how to pronounce IaaS, maybe. So this is something called infrastructure as a service. So these terms might come up as you explore and talk about cloud computing. And infrastructure as a service, I guess, is the fundamental availability of compute resources. So that is a big data center, and they go, oh, here you go, here's a virtual machine, here's a computer, you can do whatever you want with it, here's 10,000 computers, do whatever you want with it, but it's up to you to install the operating system, install the software, install everything else you want on top of it. We'll just give you the platform. And so the big ones are AWS from Amazon, Azure from Microsoft, and Google Cloud Platform from Google. And there's many others, which I'll talk about too. This other term, platform as a service, people realized that a lot of users were kind of logging on, installing the same software stacks, installing the same kind of workflows. And they went, hey, we can just cut out all the steps where you have to go, I want to do some deep learning using Python. So rather than having to install NVIDIA drivers, install CUDA, install Python, install PyTorch, they just went, here's a service which has all those things already set up, and we'll call it a platform as a service. So some examples of that are something like Jupyter Hub, if you're familiar with it, or Hugging Face, which is like an online machine learning deployment app platform. And then at the top of the stack is software as a service. So we've all used this. If you've used Office 365 on the online portal, that is all hosted in the cloud. So I guess Office 365 could be a platform, and then each of the individual apps is probably a software as a service. So something like Microsoft or Excel, Microsoft Word or Excel or PowerPoint, like I'm using now. I'm using the online version of it. So that's a software as a service. I don't have to worry about anything, not even the installation, not the updates. It all gets managed completely in the cloud. And then some other big ones, Netflix, which you may have used. So that's a massive TV streaming thing, and you just turn it on and watch whatever you want, and everything else is managed in the cloud, but you don't even know that or need to know that it's running there. And Overleaf is just another example. So a few other sort of big cloud companies. I think the ecosystem is relatively diverse. Like Amazon has a 32% market share, which is quite significant, but it's it's fairly spread out. So a few others in this sort of next 20 include familiar names like Alibaba, IBM, Salesforce, Oracle, Tencent. I've thrown in a few others that are kind of a bit more bespoke. So Doug is an Australian service. So, a lot of these are big sort of American-based multinationals. So it's good to have some local competition as well. And Lambda Labs is just one that I personally like, which has GPUs available for much cheaper than some of the big ones. So it's good to know they exist as well. Okay, so let's go on. All right, so that was basically like all my main slides. So now we're going to do some demos. We'll see how we go. Okay, the first one, I should just point out, are there any questions at this point? Everyone happy? Good stuff. Okay. All right, let's get stuck in. I'll post these in the chat too, so you can play along at home if, oh, whoops. Okay, I might just have to kill this. Let's go back. There we go. Okay. All right. I'll just click in here. Hopefully everyone can see my Amazon dashboard. So I've already logged in. If you haven't logged in, it'll probably take you to a login page. And this is the cloud. So welcome to the cloud. When people talk about AWS, Amazon Web Services, it's very confronting. It's very formidable. There's lots of things happening on this page. There's lots of buttons to click. It's confusing. You have no idea where to start. So if I click over in services and click all services, there's literally hundreds of services, everything from the basic, here's just a computer, do what you want with it, to things like hosting a database, so specific infrastructure to host databases. They have tools like you can, every time you click a button on a website, that will spin up a machine, run some analysis or run a function, and then return a result to the end user, and you pay per click basically. So that way you don't have to host all this redundant infrastructure. You just pay every time someone clicks, and it might take a fraction of a second for your task to be done. But if you have 10 million people clicking on it, it can add up in cost, and that's why these kinds of services exist. Anyway, so there's hundreds of them. Oh, another great one is you can pay a guy to come out, drive out and put a USB in your local computer, and then drive it over to the data center and plug it in at the data center. And so that's another service that they provide that's here, which is all part of the cloud computing. You know, how do you get big data onto the cloud? Sometimes that's the best answer for that. Okay, but if you just wanted a computer, something, you know, you probably have, might not have an idea of what to get. The main one, I guess, that most of the other services are built on, it's called EC2. And yeah, I don't think you'd ever guess that, but that stands for elastic cloud compute. So it's EC squared, I guess. That's where the name comes from. And this is basically a virtual machine. So this is a computer just for yourself. It's virtualized. It's hosted in some data center somewhere in the world. You can specify where exactly. And here we go. Hopefully it loads up. This is fairly confusing too when it does eventually load. So this, you know, we've finally decided which Amazon Web Service we want out of the hundreds available. We want an EC2 instance, which is just a plain old virtual machine. And now we can click on anything we like here, but there's still a lot of buttons to click on. But if we just want to make that happen, we want that computer that we can log into and start running our research on. I can go down here and click Launch Instance. And click Launch Instance. Here we go. Get there. It's thinking. All right, live demos are always a risk, aren't they? So let me just. I'll wait for that. Okay. All right. Well, that's thinking. Oh yeah. Here we go. Okay. Let's see if we can do this. So we finally get to a page where it's saying, okay, you can launch an instance and you can start paying for the privilege of it. You can give it a name. You know, my cloud computer. So that comes up, and then we come to the fun part, which is actually deciding. Oh, here we go. Very struggling. It's going to close that one. Struggling a little bit. Okay. Then we can pick what operating system we want on it. So we say, okay, what operating system would we like? So there's a bunch of different options available to us, and so we have Amazon, we have Mac OS, Ubuntu, Windows, and a bunch of other Linux flavors. You can also install like pre-made ones that have different types of going back to the AI and machine learning sort of research that you might do. You can select one that already has NVIDIA drivers, has all the PyTorch and everything already installed. You can have things that serve an RStudio for you. You can have things with you know, bespoke bioinformatics workflows with hundreds of tools or packaged already ready to go. So that's the beauty of it. You can select the machine image, and then once you select the machine image, you can go and pick what's called the instance type. And this is, I guess, the really fun part, where you can pick which sort of how they're called flavors. So flavors will be how many CPUs, how much RAM that you think you need, how many GPUs are you going to need in this cloud computing bit of infrastructure. Okay. Don't know why my computer's struggling so much. Might see if I can. Yeah, let's yeah, okay. we'll come back to this because I'll do the same thing in another dashboard. Hopefully that'll free up resources by then. But anyway, the point is that once you log on to AWS, you decide what service you want. You go through, you have to pick all these options, and to be fair, it's fairly confusing. Once you kind of know how to do it, you get the hang of it. But there is definitely a steep learning curve. You have to select sort of the networking, like the security and everything for it. You have to use another service to pick how much storage you want attached to it. And then you have all these other options too. But basically you click launch instance and you're ready to go. So I won't do that just now. I'll close this tab, hopefully give me some resources. And the next one I'm going to go to is Azure. So this is Microsoft, I guess, option. And the Microsoft option, it's basically the same as AWS. So except obviously every single service that's available here has a different name, just like AWS. So if you know the name of something in AWS, you have to try and figure out what it's called in Microsoft. So in fact, yeah, if I search for EC2, they call them virtual machines, but they've obviously put the EC2 tag in there. So there's some sort of similarity between it. But yeah, it's basically the same. So you come in and you pick, what service you need, you click on it and you go through the steps and you spin up a machine. And so we'll get to that soon. Okay, so that's Azure. On my list back here, I had Google Cloud. Google Cloud's the same. It has a huge bunch of services, all different names that you can also use. So I won't demo that. But the next few, I'm going to talk about the ARDC Nectar Cloud. So this is a cloud which is provided by the ARDC. Now, Sydney Uni used to be part of Intersect, which is linked into the ARDC Nectar Cloud. So we don't actually have access to this anymore, but you can still log in via AAF. So it is, it's connected by a single sign-on through the university's AAF. And you can log into this cloud. So this is a different cloud, basically a different data center. Although a lot of these clouds, they live in the same data centers. So they'll have racks in one data center and they belong to Amazon. Then right next to it, they'll have racks that belong to Microsoft or to Nectar or something like that. So, okay, so yeah, so you can log on to the ARDC cloud with single sign-on, just sort of proving that point there. Yes, I approve, sure. Let's see if I get there. Okay. Cool. So it's come to another dashboard, and I can click on my projects here and click on compute. So this one has, I guess, less options than something like AWS or Azure or Google, and they sort of make it a little bit simpler. And you can click on an overview and see how many CPUs and everything you're using. I have none out of none. I don't have any allocations in this. So as an Australian researcher, you have access to this, but yeah, we don't have any paid allocations via Sydney at the moment. However, very similarly, there are two large national compute facilities called Pawsey and NCI. And so they offer their high performance computing systems. That's their main, I guess, flagship product that Australian researchers can get access to via various merit schemes or just applying. And we also buy time. We buy time and provide that to researchers through a few different mechanisms. And they also offer their own cloud computing. And so I'll go to the Pawsey one, which is here, and it looks very similar to the ARDC Nectar Cloud. That's because it's all built on the same infrastructure that all three of them are built on the same infrastructure called OpenStack. And OpenStack it's an open source way to build your own private clouds, I guess. So we could all get together, everyone in this chat, and put our local computers together, install OpenStack, and then link them all together and make our own private cloud, and then only give access to whoever we wanted. And so that's what Pawsey has done, although they have their own data center. Same with Nimbus and NCI. And you can see I have a machine already here, which is kind of cool. So I have a project here that has a certain amount of allocation. So you can apply for allocations to Nimbus, and yeah, depending on the merit behind it and also how much you ask for. So if you ask for very few resources, say you only need one CPU or a bit of RAM, and you just want to do some very light work, but you just need this permanent bit of infrastructure that you can always connect to from anywhere, this is a really good service for that. Or if you need a dedicated machine to host some like web app or something, this is also a good service for that. And I can, I have my thing there. I can just click start. It's been shut down for 4 months. If I click start, I can boot it back up. Oh, it's kicked me out. I guess I wasn't logged in. So I'll just log in with my credentials, and it'll take me back. But yeah, so that's OpenStack. The link I will post the link to the Pawsey, and that one will see, there we go. I'll post this link. This gives some more details about it. I see a few questions. I'll stop in a second and address any of those. Okay, yeah. So that's Pawsey. I haven't shown you any compute. I'll get to some actual compute. I think coming up in a moment. But you can see now my machine. It's still shut down. If I click start, it will just turn it back on. And you can see that the flavor here is an N32C8R, which I mentioned the term flavor before. That's basically how many resources for each machine. They all have weird names like this, and there's no way to learn them unless you memorize them or use it a lot. But they normally have good documentation that you can look it up. And this one in particular has 2 CPUs and 8 gigabytes of RAM, and it's a 40 gigabyte drive. Okay, so all right, let me address some of the questions in the chat. Let's see, what have we got? See, Chow's been answering. So how secure are these services with regards to potentially sensitive data, people using their research? Great question. So most of these, in fact, I think, yeah, getting highly protected data onto them. We don't have anything that's you can just put highly protected data on, but I mean, it's all up to negotiation. So if you, so I'm about to talk about Ronin, which is the Sydney Uni one. It's only cleared for protected data, but you can sort of write into your ethics agreements, how you're going to handle that data management practice, and also the national facilities as well. They have various security protocols in place, which make it somewhat safe, much safer than just the public clouds, which your data might be copied over to somewhere else in the world and then brought back in. So these 4, I guess, are the ones that you want to focus on. And so we'll talk a bit more about that. And does the university cover the cost? Short answer, no. There is some, like I mentioned, there is some merit schemes that we have. So we just recently closed our SIH HPC scheme, which gives time on NCI, and that time can be used for cloud compute as opposed to just high performance computing compute. And then there's other merit schemes that get you onto Pawsey. There are, if you have any collaborators at a bunch of other universities, I think UNSW, UTS have Nectar collaborations, and so they can get time on that. And then Ronin, there is some sponsorship by ICT for projects that can get people sort of onboarded, and then it's research funded from there on, which I'll talk about in a second. And okay, and what would be the advantage of using Pawsey over Artemis? So I guess Artemis, I'm going to demo Ronin now. So Artemis is just a pure high performance computer. It's very limited. You can only install things in your home directory or project. You have finite resources, limited space. You don't have root access. So in the cloud, you can build your own Artemis if you like, and expand it to whatever you need. So let's do that. Let me close on a bunch of tabs. So Ronin, this is probably our flagship cloud product from the university. So Ronin is basically a front end to AWS. So it's a nicely skinned version of AWS, but it also has, it's only in the Sydney data center. So your data will not be leached out to the rest of the world. So we have agreements with AWS. We are on the Sydney network as well. So you have to be connected to the VPN to connect to cloud infrastructure through this Ronin platform. And it's also much easier to use. There aren't a thousand different options. You basically log on and it looks something like this. So I'm in my project here and it tells me, I've spent this much. You can set budgets and everything, and you can see what's running and how much storage you have allocated and so on. And so now if you want a machine, you can click machines, new machine. And it's probably much nicer than the AWS interface. Gives us several options for our operating system. So we can pick a Windows machine. Let's go Windows 2022 or Ubuntu or something. We have a bunch of pre-configured ones as well available, and we can expose different ones as required. So that's it. I can give it a name. So like we did before, cloud demo. Okay. And then I picked my machine type. Now I spoke a bit earlier about how we have these different flavors here. So there's a quick select where we can pick a small one with 2 CPUs, 2 gigabytes of memory, 4 gigabytes of memory, or 8 gigabytes of memory. Or we can go down and sort of scroll and say, oh yeah, I want like a machine that has 488 gigabytes of memory and 64 CPUs. So I'll select that one, and that's it. And then I click launch. I'll pick a smaller one for demo's sake. So you can also see the cost of these. It ranges from very cheap, a couple cents per hour for the smallest ones, 0.4 cents per hour, 0.04. Sorry, $0.04 per hour. So 4 cents per hour, up to I think the most expensive is about $30 per hour for some of the big GPU machines. But the benefit of Ronin is it's very transparent with cost and everything like that. Okay, so then I click launch, and for Windows, it always asks for a password. So I need to provide a password. Okay, that one worked. Okay, I'll launch my machine. Good stuff. Show the machine. All right, and it should only take a minute or so for it to boot up. But that's it. Then we have our own Windows machine. And currently it has 2 CPUs, 15 gigabytes of RAM. We can do a whole bunch of configuration, modify it, and then install software, move data across. And then when we're ready to actually perform our analysis, we can then reconfigure it and put on like a massive machine, something with hundreds of gigabytes of RAM and multiple CPUs. And then we can do our analysis, turn it off, and reconfigure it down to a small machine. So that's sort of the paradigm that cloud computing uses. Kind of use just what you need at that time, rather than just having these resources sitting idly, or something like Artemis, where sometimes it's really busy, sometimes it's quiet. With cloud, ideally, you should just use it as you need it. And let's see, is that finished yet? Here we go. Cool. So it's done. So I'm going to click IDP, and I will see if I can launch into it. I might have to reshare my screen. Stop. Okay. Hopefully everyone, oh, yeah, did that work? Share, desktop, share. Okay, so I've just opened up that little file that I downloaded, and we'll see if this works. Hopefully it works. Oh, okay. I think this is a bug actually for Windows machines. You have to immediately change the password, which is a bit annoying. But let me enter a new password. Let's try again. Okay. So I will connect. I just use this bit of software. If you're familiar with SSH, then that's how you connect to a other machine. Oops, I've connected to a different the wrong machine. Let me try again. Yeah. Sorry. Live demos, downloads. Okay. Hey, there we go. So here we are. We're in our own private Windows machine that we can do anything we like with. It's booting up. Might take a moment to boot. The first time, after the first time, it's normally pretty snappy. But yeah, so in theory, it should be as straightforward as that, going from 0 to however much resources you need in the space of a few clicks. Hopefully everyone can see the Windows machine. Please let me know if I'm embarrassing myself by not showing that on my screen at the moment. But yeah, there we go. So, and now we can do whatever we want with this machine, install any software that we need. And then once you're done with it, you kind of you can turn it off. You can stop it, and then it's all of a sudden costing you nothing or very close to nothing. You still pay for storage. But there we go. Okay, any questions in the chat that's come through? Okay, good stuff. George is all over it. All right, so I'll show you one more thing with Ronin, just for those that are more familiar with working with high performance computing clusters. There is another service, it's called Auto Scale Clusters, and this plugs into a couple of Amazon services. It basically lets you build your own supercomputer in the cloud. So I can click on new Auto Scale cluster, can make it Ubuntu. I'll give it the Slurm scheduler. The one we have on Artemis is PBS, which Torque is the equivalent of, but I have found this one a bit buggy. So I normally stick to Slurm, but it is there in theory. I'll call this demo. I won't launch this one though, because this one takes about 10 minutes to configure. All right, and then I pick my my head node or like the login node that you would with Artemis. So again, we get this menu of flavors. So I can say, oh, I just want for my my local machine, I just want 2 CPUs. So that's the one that's always on. But then my compute nodes, I can say, okay, give me some big GPU machines with huge amounts of CPUs, and let's do that. And I can set the size of my my directories, so how much space I need. And here's the fun part. I can say, okay, have no machines until I call them with a PBS or a Slurm script, and then give me 100 of them. And so I can have up to 100 nodes. So this machine is now bigger than Artemis, and at the click of a button, basically. And if I'm running it relentlessly, it's going to cost $56,000 per week. But if I only use it for 10 minutes, then it could be worth it. If I spin it up, run my job for an hour or two, maybe, then you get everything done really quickly. You don't have to wait in queues or anything like that. So that's super cool. And yeah, and so you can plug in as much storage and whatever you need into that as well. So there we go. So we saw a cloud machine in action. But yeah, once you actually see the cloud machine, it's just a machine that you remotely log into. So there's nothing more to it, but you have full administrative control over it and you can do whatever you want. Okay, and yeah, maybe another one just worth talking about is like Google Colab. So the uni doesn't have any, I guess, collaborations or affiliations with this, but it's a really useful tool that people will use a lot in research. So it's basically more like a platform as a service. So this is running on the Google Cloud infrastructure, and it's just running a Jupyter notebook with a GPU in it. So if you haven't seen this before, it's very handy. But you can make these public and share them with people. You can make them sort of read only, so people can come in and modify it, but then it'll keep it as is. If you're familiar with Python, I've got a machine here now that has Python on it, and I can run whatever I like. Again, at the click of a button, you just need a Google account for that. So yeah, we have found that a lot of people use this kind of thing. And yeah, all right. The question, how do you pay for it? So, okay, let's go through it. Actually, I'll go to my next slide. This is my little diagram that I've made. Depending on, I've just shown you a few services, but there's many dozens of services that are possible. So let's expose them all here. So if you have cash, I'd recommend kind of these ones over here. Now, AWS, Azure, and actually all of these ones here that if you just have the right tool, if you just need the right tool, you can pay with them, I guess, through a credit card, and then it will you can go from there. However, we do have university integrations with these three over here. That's what the little red tick indicates. And that way you can pay with like journal transfers if you set up your accounts via the uni and use the services via the uni. And then if you are more interested in sort of competitive merit schemes, then I recommend Pawsey and NCI for that kind of thing, where you can sort of request a certain amount of hours that you want, and you have to describe the workflows that you're actually running on it. You still get kind of similar resources, but you will, I guess, be given a limit to how many resources you can spend. I should mention, though, there are merit schemes for both Google and AWS and Azure and Ronin and probably other things as well, that they run kind of perpetually, and you can apply for merit directly with those organizations. Competitive merit is just, you would have to put in an application saying like, I'm the best researcher, you should give me this and not give it to other researchers. Look at all my credentials, here's the cool science that we're going to do with it. So you fill in like a grant, exactly. Yeah. Oops. Okay. Sorry, I'll just okay, and then yeah, if your collaborators use it, I mean, by all means, Google Cloud or Nectar, they're the way to go, or even any of the other tools as well. So it's really hard to say which tool should I use just straight off the bat. But if you want to reach out to us and ask about any in particular, then I can probably give you some guidance around which one to use specifically. Okay, so and what's happening in the future? Basically, there's a couple initiatives taking place. One is the Research Cloud Initiative, and this is taking our current on-premises Artemis and platforms like Ronin that we support as well, and kind of trying to tie them more together and integrate them more, and upgrade Artemis, out of our, if you've used Artemis before, it's sort of aging and stagnant, and it's a fixed resource. It basically, you install it, you pay for it, and then it just devalues over time. The future slate looks like it should be continuously sort of updated, and it moves with the cloud. That is the other benefit of the cloud. And so there are a couple of positions hiring soon to kind of get that project off the ground. The other one is the Research Platforms Initiative, and that is integrated with ARDC. And so that's working more towards having specific platforms that researchers use. There's a couple already, like XNAT and the Australian Imaging Service. I think it's still called that. So you may have used that, and it's a way that is a way to handle highly protected data when you have the platform already integrated, and you can it does a specific task. The platform, I guess, you might upload data there. You might have a few tools that you can select and run. So the Research Platform Initiative will be rolling out kind of more platforms that researchers use over the future. All right, so that's everything I had prepared. So if you have any questions, or if you want to ask specifically about your research project, visit our website and click on the big red button. Or send us an email. Internet's taken away. Oh, here's one I prepared earlier. Okay, yeah. So if you click on Contact Us on our website, you can fill in a kind of request for support or request for more engagement form and go from there. Or else, please send us an email and someone will respond. So I'll just post that in the chat. Oops. Oops. There we go. I'll get there. There's my Zoom chat. Chat. Okay, yeah. So thank you very much. That's everything I have to say today. So if there are any more questions, feel free to ask them. If not, have a good day. Fantastic. Thanks all. Today's slides, yes, we recorded the session, so I'll make them available. And yeah, I'll share the recording. Anyone who registered will get the recording and the slides. No worries. It is also all available on specifically the link to the I guess I have a specific link. Thanks for dealing with my slow, buggy internet. Research data platforms. Here we go. I have a bit of a summary on this site as well. All righty, no more questions. Thank you very much, everyone.